There is probably a little rule breaker floating in a drink somewhere near you right now, and you have never once thought twice about it. An ice cube, bobbing at the top of a glass of water, a piece of it poking up above the surface. It looks like the most ordinary thing in the world. Of course, ice floats, you think. It always has. But here is the twist that made me stop and stare the first time it really landed for me. That calm little cube is quietly breaking a rule that almost everything else in the entire universe obeys. Nearly every other substance, when it turns solid, does the exact opposite of what that ice cube is doing. Water is weird. And stay with me, because the reason it is weird is also the reason fish are alive under a frozen pond this very winter. I'm Mister. Why? And let's start with the rule that ice is breaking, because once you see the rule, the trick becomes wonderful. Think about almost anything else that melts and freezes. Take a candle. The hot liquid wax at the top of the flame, if you drip it into the solid wax below, the solid sinks, it sits at the bottom. Melt a metal, and the solid lump drops straight through the molten liquid. For nearly every material we know, the solid version is heavier for its size than the liquid version, so the solid sinks in its own puddle. That is the normal rule. Freezing something usually makes it pack tighter, get denser, and go down. So water should do the same. Freeze it, and the ice should sink like a stone to the bottom of the glass. But it does not. It rises. It floats. Why? And here is the twist that flips the whole thing inside out. You picture freezing as a big squeeze. Things get cold, they huddle up, they pack together, they get smaller and heavier. For almost everything that is true, but water does the opposite. When water freezes, it does not squeeze in. It spreads out. The very same amount of water takes up more room as ice than it did as liquid. It puffs up, it opens out, it gets bigger and lighter for its size. That is the secret in one sentence. Ice floats because frozen water is roomier than liquid water. Now let me show you why on earth it would do something so upside down. So picture a single drop of water as an enormous crowd of tiny people, and every one of these little water people has a few little arms reaching out. In liquid water, the crowd is loose and jostling. Everyone is shuffling around, sliding past each other, bumping shoulders, packing in nice and close wherever there is a gap, filling every little space. Liquid water is a busy, tightly packed, ever-moving crowd. That is what lets water pour and splash and take the shape of the glass. The little people are close together because they are free to slide into every empty spot. Now cool that crowd down, colder and colder, and something changes. The little water people stop shuffling. They slow down. And at the freezing point, they reach out those little arms and lock hands with their neighbors, and they hold on. They stop sliding past each other and settle into fixed spots, each one bonded to the ones around it, all frozen into place. In science, those little arms have a name, hydrogen bonds, but you can just think of them as the water people holding hands. And the pattern they hold hands in is the whole secret. Because when they lock into place, they do not clump into a tight little ball. They snap into a neat, rigid, six-sided frame, a repeating pattern with wide open gaps in the middle, like a honeycomb, or like people forced to stand in a strict ring holding hands at arm's length. And a ring at arm's length holds everyone farther apart than a jostling crowd that can pack in close. So this fixed open six-sided frame actually pushes the water people farther apart than they were when they were loose in the liquid. The frozen pattern has empty rooms built into it. There is more empty space inside ice than inside liquid water, and that empty space is everything. Remember, the amount of water has not changed. It is the same little people, the same amount of stuff, but now they are spread out across a bigger, roomier frame, with gaps between them. So the same amount of water takes up more space as ice. And when the same amount of stuff is spread into a bigger space, it is lighter for its size. Scientists call that being less dense. Ice is about 9% less dense than liquid water, roughly 1 part in 11 lighter for its size. And anything that is lighter for its size than water will float on water. That is the whole trick. The open, hand-holding honeycomb frame makes ice roomier and lighter, so up it comes, and it bobs at the surface with a little bit poking out into the air. And water has one more stubborn little habit that makes it even stranger. You might guess that water is heaviest, most tightly packed, right when it is coldest, right at the freezing point. It is not. Liquid water is at its most packed, its densest, at about 4 degrees above freezing, a little bit warmer than ice. Cool it past that point, down toward freezing, and it actually starts to spread back out again, getting slightly roomier and lighter as it gets ready to turn to ice. So water reaches its densest a touch above freezing, and then reverses and puffs up on the way to becoming ice. Water simply refuses to behave like everything else, right down to the last few degrees. So now the part I really want you to keep, because this tiny quirk does something enormous. Think about a pond in winter. As the air turns freezing, the top layer of the water gets cold and turns to ice. And because ice is lighter for its size, that ice does not sink. It floats, and it stays right there on the top. So a pond freezes from the top down. A lid of ice forms across the surface and just sits there. And here is the beautiful part. That floating lid of ice acts like a blanket. It seals off the cold air above and holds the warmth in below, so the water underneath stays liquid all winter long. And down in that liquid water, safe under the frozen roof, the fish keep swimming. The frogs settle into the mud. The plants wait out the cold. A whole little world stays alive under the ice, all winter, kept liquid by the floating lid over its head. Now imagine, just for a moment, that water behaved like everything else, and ice sank. Picture it. The top of the pond freezes, and that ice, being heavier, drops to the bottom. Then the next layer freezes and sinks. And the next. The pond freezes from the bottom up, layer after layer dropping down, until the whole thing is a solid block of ice from floor to surface, with nothing liquid left anywhere. And everything living in it, the fish, the frogs, the plants, would be frozen solid and would die every single winter. Whole ponds and lakes would turn to lifeless ice. The only reason that does not happen, the only reason there is life waiting under the winter ice, is that one strange rule water breaks. So here is the surprising part, the thing that quietly rearranges how you see a glass of water. That ordinary ice cube floating in your drink is not doing an ordinary thing. It is showing you the exact same trick that keeps entire lakes alive through the winter. A tiny quirk in how water molecules hold hands, locking into an open frame with empty rooms inside, is the reason ice floats and the reason ponds freeze with a warm liquid world sealed safely underneath. Something, almost nothing else in the universe does, happening quietly in your glass and out there keeping fish alive under the ice. So here is what I want you to carry with you. The next time you drop an ice cube into a drink and watch it bob up to the top, you are not watching something boring. You are watching water break a rule that almost everything else obeys right there in front of you. That little floating cube is the same stubborn quirk that lets a frozen pond keep a whole world alive underneath it. The water people locked hands into a roomy honeycomb, puffed up, got lighter, and rose to the surface. And because they do that, there is life waiting under the winter ice. One broken rule, one open frame of hands, and a whole living world says thank you. So the next time you hear that little clink of ice against the side of a glass, you can smile, because now you know the secret. That is not just a cube floating. That is water quietly refusing to follow the rules and keeping ponds alive while it does. Now, I would love to know, down in the comments, had you ever noticed that ice floating is actually strange, or did it always just seem obvious to you? And is there an ice cube floating somewhere near you right this minute? Go and look and come tell me. And if you enjoy having the most ordinary things around you quietly taken apart until they finally make sense, subscribe and stay for more simple lessons from Mr. Y.